Okay, let's continue our look at regular expressions by talking about quantifiers. And you may remember at the very beginning I brought in a slide that shows us all the major entities involved in regular expressions. We sometimes call it the bestiary because it has these special entities, strange and wonderful beasts. And I boiled regular expression bestiary down to some just basic categories. First, the anchors that says I match at the beginning or I match at the end. Then the character classes, which say I match on any one of this group of characters. And then finally, the quantifiers, that says how many, and then the groupings. So in our first video, we looked at the anchors and the character classes. And now let's continue on with the quantifiers, which specify how many. There are some built-in quantifiers. These quantifiers say 1 or more, 0 or more, or 0 or 1. And then we also have custom quantifiers, which specify how many in their own way. Let's look at an example here. It's quite common that we might have files that match a particular pattern, but they may have, let's say, a number involved. This would be a file, let's say that we had a series of configs and that they're numbered. So again, we have the example of a file listing that may contain file names that we want and may not. Not this and dot should be rejected, but if we're interested in just looking at the config files in our directory, we might want to look for this. And so what is this pattern? Well, if it can match on config_1, but it could also match on config_10, obviously we're not just talking about matching on a single digit character, we're really talking about matching on one or more digit characters. And that's what the plus is for. The plus, as we said before, means 1 or more. And the quantifier will be applied to whatever immediately precedes it. So this says 1 or more digits. A digit followed by a plus means 1 or more digits. Therefore, it will match on config_1 and config_10. Indeed, config_ any number of numbers. Let's look at an NYU net ID. Are you familiar with the net ID? NYU net IDs look like this. DBB212 is one. ML14, JJ2, AXE43. For, let's say, 439. Any one of these will match an NYU net ID. Your net ID is no different. So of course we see that there's a pattern here. It's lowercase letters followed by numbers, but we can say more specifically it's 2 or more lowercase letters, or we may even say 2 to 3 lowercase letters. But let's say 2 or more, followed by 1 or more numbers. Okay, this is actually being more specific. The plus after the digit says 1 or more digits. But preceding that, we're saying that we're going to have 2 to 3 letters. And I guess I'm being a little less specific. I believe an NYU net ID is always lowercase. I could be wrong about that. Doesn't really matter. We can specify it any way we'd like. If we'd like to match the net IDs that we see here, we might say A to Z, 1 or more, followed by 1 or more digits. That's our idea here. This custom quantifier we'll look at again, but you can see it means 2 or 3. So maybe we'd like to say 2 or more instead of 1 or more. I could say it this way. So you see how the built-in quantifier plus, which means 1 or more, is being applied to the digit. And the custom quantifier 2, space, that's being applied to the letter character class. And so we say, and we can write this out, 2 or more letters followed by 1 or more digits. We could also look at other examples like an email address, which says one or more word characters, so that can include numbers, letters, or underscore, followed by an @, literal @, followed by one or more word characters, again, letters, number, or underscore, followed by, why do I backslash the dot? Remember we said that a dot actually means something special in regular expressions, so we backslash that, followed by 2 or more letters. Now you're starting, and then you can also see that this is anchored from the beginning to the end, so it won't admit of any other characters in there. So you can start to see how the combinations that we've learned so far are beginning to come together to indicate sophisticated patterns. I'll read this one again. From the beginning, one or more letter, number, or underscore, followed by an @, followed by one or more letter, number, or underscore, followed by a dot, followed by between 2 or more letters, and then anchored to the end. That's a simple email address. Obviously, email addresses are far more sophisticated than this, but we'll just say a simple email address could be matched with this pattern. Now, besides the quantifiers, and besides the character classes, and besides the anchors, which again, remember, that's really all we were talking about in the beginning, just anchors, character classes, and quantifiers, and we'll look at groupings in a moment. There's also a number of flags that are possible. One of them is ignore case. The flag would appear as the third argument in a search. You can see that this is going to match on any of, and some file systems do this, it's going to look for .txt at the end of the string in this file name. But as you can see, our particular listing here has both uppercase .txt and lowercase .txt. And although it might be possible for us to match on that more specifically, we can also say, just make it .txt and let's ignore case. And that's what that third argument is for. Now, when we search, there is a way to compile a regex ahead of time. I'm going to let you read this slide on your own, and I'm going to move on from here. The last thing that we're going to look at is grouping. Grouping is represented by parentheses, and grouping can be used for 3 different applications, 3 different reasons we might want to use groupings. The first that we'll look at is alternates. The grouping alternate says this or this or this or this. You can see the vertical bar. Vertical bar has a special meaning. It means or in regular expressions. And we can place that inside a group if we wish. If this is looking for an argument that starts with a Q, capital Q, and is followed by 1, 2, 3, or 4, we're not going to want to say \D because that could match on any digit character. If we're looking for Q1, Q2, Q3, Q4, in other words, notation of one of the 4 quarters, calendar quarters, we can say that by saying Q followed by one of these, and that's what this grouping is about. This is saying from the beginning, a Q followed by 1, 2, 3, or 4, followed by a dash, followed by 4 digits, and then ending at the end of the string. So, you know, Q3 2012 or Q2 1999. That's what would match in this instance. We can also group for quantifying. I'm going to show a slightly more complex example. If you look at these patterns of good email addresses and you compare them to what we have below, you can see that there's actually a certain kind of sequence that's expected in these examples. Now again, this doesn't really cover all email addresses. Email addresses also allow for dashes and things like that. But there are certain things that will be rejected by email addresses and certain other combinations that will be accepted. For example, you can say Joe at Apex. You could say Joe.Wilson at Apex. You could say Joe.Wilson at eng.apex.com. You could say Joe.G.Zebulon.Wilson at my.subdomain.eng.apex.com. Now, I don't know if you can see a pattern in this. It isn't just any letter or period. It's basically saying we could have a group of letters and then there might be a dot and then we need to see more letters. Or we could see repeating versions of this. Letters dot dot, letters dot dot, letters dot dot. Now, you could try to approximate a regex like this by saying, well, it could be a letter or a dot. One or more letters or dots. And then if you wanted to match on that, you could maybe say something like, you know, I'm looking for a character class that is a letter or a dot. I don't know if I need to backslash the dot in this character class. Do you recognize this is a character class? This is a character class. This, without it, would say, I'll match on any letter. With the dot in it, it'll say, I'll match on any letter or a dot. And the dot could be in front and it can be in back because this is a character class. A character class says any one of these. And then you could say at and then do the same thing. You know, maybe, and then a dot and then a com. But look, this would allow certain patterns that would be rejected, like .joe or .com period or joe dot dot. Those should be rejected. We shouldn't allow for those. So we can't just say a dot followed any of a dot or a letter because this would allow, I'm sorry, we're going to say one or more here, my mistake. We can't say this because this would match. Here, let's look at the example. Number. This is not going to allow, if we look at a regex like this, like the one we just described, where we say, let's say from the beginning to the end, let's look for a dot or a letter. Let's see what it matches on as good. And let's say one or more, sorry, followed by an @ sign, followed by the same character class, followed by .com. Let's see which ones these match. Oh, it doesn't match on anyone. I wonder why. Let's see. What did we do wrong here? One or more letters followed by a dot, followed by an @ sign, followed by one or more letter dots, followed by an @ sign. Clearly, I'm missing something here. Followed by .com at the end. Oh, I didn't put one or more here. Let's run that one. Now it says that almost all of them are good. Almost all of them are good. The only one it rejects, looks like, is the one that ends with a .com dot. But even ones that start with a dot, how are we going to avoid this? Well, there's one specific sort of more sophisticated way that we could handle this, and that is to notice that the pattern is either Joe or Joe.Wilson or Joe.G.Zebulon. Do you see a repeating pattern here? This is a repeating pattern, and it says Zebulon dot. So this repeating pattern can be described with a grouping that says one or more word, I'm saying one or more word characters, I could say letters, followed by a dot, and then saying 0 or more of those. looking at our examples that are supposed to work, you see Joe dot. That would be what this matches. One or more followed by a dot. And there's one of these, two of these, three of these here. And then Wilson at. Let's look at our pattern again. This would be the Joe dot, G dot, Zebulon dot. And we're saying that there may be 0 or more of these. Then we're saying Wilson, one or more letters. We're using word characters, we should probably use letters, but we'll leave it at this. And then the @ sign. And then again, we're saying that we might see subdomain dot other domain dot, here, ang.apex.com, my.subdomain.ang.apex.com. Okay, another repeating pattern of letter dot. There's our repeating pattern. But what I want to bring in here is this idea of saying one or more of this group. That's what the parentheses are doing. Without the parentheses, the quantifier plus or star would be applying only to what was immediately preceding it. In this case, a dot. In this case, a dot. This one is immediately preceding a word character. But these quantifiers are immediately preceding a group. And so they're saying one or more of this group. So you can see that I'm matching on one or more word characters followed by a dot, but then I'm saying there may be one or more of that. And that's the second use of grouping. The third use of grouping is for extraction, and this is the one we're really going to focus on. Let's say we wanted to pull out a certain aspect of these log lines that we looked at earlier. If you look over here, you can see at the very end of the log line, we have a 3-digit, looks like an integer, followed by one or more digit, also integer. And what these values represent are the success code, that is, sorry, the status code of the request. And you may remember when we looked at web requests last week, we saw this. 200 means okay. 400 means, I think, not found. Or 404 means not found. I'm not sure what 400 means. But the second set of digits here, this represents the number of bytes that were downloaded. Because as I mentioned, this is a web server log. This is indicating that this IP asked for something. It happened on this date and time. It was a GET request. They asked for this. It used the HTTP 1.1 standard. And this was the status code that I returned. This is the web server talking. And these are the number of bytes that were downloaded. You can see that this JPEG was 175K, whereas this HTML page was only 1,500 bytes. Okay, our goal will be to try to extract the status code and the number of bytes from the web server log. And how can we do that? Well, we can do what we might have done to try to construct a good regular expression, saying I'm looking for one or more digits, followed by a space, followed one or more digits, and at the end. At the end, very important here, of course, because you never know where you're going to find one or more digits followed by a space, followed by one or more digits. But if you're specifying at the end, you know you're going to get them at the very end of the line. And that's what this anchors for. More importantly, what we're doing right now is we're grouping those two values, because if we're interested in making use of the values, not just validate that they were there, but make use of the values, we can do that by grouping them. What we then do is, instead of putting search into an if, you can see that we're putting the search as its own statement, and we're assigning the call to search to a variable name. Doing that indicates that we are taking back an object from search. And what this object is a very special regular expression object. Before, we used to say re search inside an if statement, right? And that was basically just checking to see if it matched or not. Now we actually want to make use of the match and learn something about the match. We do that by assigning it to a variable. See, it wasn't true or false at all to begin with. It was really a special object. And this special object can be queried. Sorry, here's the object. This special object can be queried. We can call group 1 to get the value that was matched here, or group 2 to get the value that was matched here. And what are those two values? Well, you can see we're looping through each of the lines of the file. Each one of the lines has these two values, and we want to extract them. Why don't we look at another working example for that? Grouping for extraction. Here's our example. And you can see that I've got 200, 200, 400, 17, 15, 11. What I'm doing is I'm looping through each row, each line in the log lines. I am matching on the status code and the bytes at the end of the line. And I am using group 1 and group 2 to extract those values. So remember what we had up here. Let's take a look. Now you can see that I successfully extracted the 200, the 200, and the 400, and the 175,000, 1,500, and 1,100 using my groupings. For each line, I matched on the line. I grouped the two places where I have digits being matched, and I extracted them using group 1 and group 2. So this is the third use of extraction for regular expressions. This means that we can go through any text at all and extract any text that matches that pattern. Groups is similar. Groups will give us a list of the groups. Find all will find all of the matches within a text. This is looking for one or more word characters. And can you identify one or more word characters in this string? There's one or more word characters. There's one or more word characters, etc. If you use find all, it's actually going to pull them all. It's going to find the first group, the first one or more word characters. Then it's going to stop matching, but it's going to keep going and say, oh, one or more word characters, okay. One or more word characters, okay. It can find them all, and it's going to return them in a list. If we use groupings, it's a little more complex. I'll let you look at that example yourself. Basically, if you use groupings within what you're looking for, it'll give them to you in a list of tuples, but I'll let you examine that one. We can also use regular expressions with substitutions. These aren't really great matches because we're not actually using regular expressions here, but the first part here could be a pattern, and it will substitute anything that matches the pattern with whatever you'd like. We can also consider that regular expressions can match on really anywhere within a string. This is like a whole large string, and we're running a pattern on both. And I think I'd like to show you these, so I'm going to do it. The last bit that I want to show you has to do with matching on multiple lines of text, that is like a whole file. We want to consider that because we might be presented, and we will in the homework, we might be presented with a large bit of text, and we want to find everything that matches within it. And the text might be multi-line. Now my question to you is this: what if I wanted to match starting at the beginning of a line, but rather than going line by line, I want to consider the whole file at once, and I'd like to be matched at the beginning of a line. If I'd like to do that, I can use the anchor. As you can see, I'm doing that here. I'm saying anywhere within the file, I want to find root colon and then these patterns. And I don't know if you can remember what this is. This is saying one or more non-colons. That's what that's saying there. I'd like to match at the beginning of a line, not at the beginning of a string. That's what the anchor would normally mean. The beginning of a line. If I use this special extra flag, RE multiline, then a caret will match at the beginning of a line within a multi-line text, and a $ will match at the end of a line of a multi-line text. There's also the .all, and you might have to study this example to get it, but if I had one big string that was one file, and you can see I'm reading this file as a single string, which means that my regex string, I mean this is a string that I'm going to be matching on with my regex, actually has many lines. Maybe I'm just interested in the middle part. I want everything between start text and end text. And so I might like to employ something like this. From start text, followed by one or more any character, followed by end text. The problem with this, and you know, the dot is really versatile in this case. It will match on just about anything. It doesn't matter if it's punctuation, characters, space, it doesn't matter. The problem though is that the dot by nature, by default, will not match on a new line character. Now if I'm considering this text as one big string, and I want to say starting with start text and then any character between here and end text, I'm going to want the dot to match on a new line. So I can add yet another flag called .all, which will match on any character including the new line. You might want to study this to make a little more sense of it. The last few things that we just talked about, I talked about very cursorily, very, very briefly. So you may, hopefully when we get to class and some of our examples, we'll see a lot of this more clearly. But I hoped that just in 1 hour, I could summarize what we're going to cover so that you can get a first pass at it before we have class, or to review what we did after class. Okay, great. I hope you enjoyed this 2-part introduction to regular expressions. I will see you in class.